Welcome to our forum on South Fork Wind, New York's first offshore wind farm. I'm Julie Ty, and I'm president of the New York League of Conservation Voters Education Fund. NYLCV Education Fund's mission is to educate, engage, and empower New Yorkers to be effective advocates for the environment. This evening, we're happy to be joined by our event partners, Citizens Campaign for the Environment, Group for the East End, Reliable Energy Long Island, and Win with Wind. One of the most important steps we can take to reduce the effects of climate change is to switch our energy to renewable sources. 2019's Historic Climate Leadership and Community Protection Act legally commits New York to this priority, with a mandate to obtain 70% of its power from renewable sources in just 10 years and transition 100% to 100% clean energy by 2040. The act also includes the largest offshore wind goals in the country. We must reach 9,000 megawatts of offshore wind energy by 2035. Making it a growing power source that will play a major role in our clean energy economy. And just a few months ago, Governor Cuomo announced the largest combined solicitations for renewable energy ever issued in the United States. South Fork Wind will help us get there. In addition to generating energy that will power more than 70,000 homes each year, it will provide more than $29 million of investments to the local community. Tonight, we'll hear more about this project. We're holding this forum for you, because we believe it is important for project developers to provide meaningful information to the community and communicate local impacts. There are aspects of this project that have been discussed elsewhere which will not be touched on. Our forum this evening is focused on the timing of the project, what you will see and hear during construction, and what's happening on the beach and near the shore. First, we will hear from East Hampton Town Supervisor Peter Van Scoyoc. Then we will have a short presentation by the South Fork Wind team on the nearshore and onshore impacts. After that, Joe Martens, director of the New York Offshore Wind Alliance, will lead a QA session based on the many questions we received in advance of the event. We'll also have time for some additional questions from the audience. To answer one of the questions we received already, yes, we are recording this and it will be made available on NYLCV's YouTube page after the fact, and we will send out that out in an email to all participants and people who signed up for the event who could not make it. So to kick things off, I am pleased to welcome Supervisor Van Scoyoc.
Thank you very much, Julie. It's a pleasure to be here tonight to discuss one of the most important issues facing our world today, and that is to transition away from fossil fuels and to move to more efficiency as well as green renewable energy sources. The town, starting in 2014, became the first municipality in New York State to meet 100%, to adopt a 100% renewable energy goal. And that would be for all renewable energy sources in electricity by 2020 and the equivalent of 100% by 2030. This was an extremely ambitious goal, and we've pursued that ever since. I got on the town board in 2013, and for the last 4+ years, we've been discussing the South Fork Wind Farm and bringing it into our town as a response to LIPA's RFP. This is a necessary part of reaching our 100% goal. We cannot derive enough energy from solar alone. In East Hampton, it probably would only amount to about 14% of the capacity we would need. Personally, I've installed photovoltaics on my own house, and I am more than 100% renewable, pumping extra energy back onto the grid, but not everybody has that ability. We have a lot of areas in town that are wooded. We've continued along our path since then. We adopted a climate action plan, studied microgrid feasibility for East Hampton Town Hall campus and surrounding buildings to provide energy. We were awarded in 2016 a bronze certificate from New York State Climate Smart Communities, and that program granted us $100,000 in grant funding. We were certified as completing 44 actions involving inventorying of emissions, decreasing energy demand of municipal operations, encouraging renewable energy. We've consistently sought to protect our very precious climate and here locally our pristine wildlands, waters. We've seen environmental damage and degradation from harmful algal blooms in our local ponds, creeks, and bays. This is the result of nitrogen, which comes not just from septic systems, but also through atmospheric deposition, not to mention the impacts of other chemicals that precipitate out of the atmosphere as a result of burning fossil fuels. The economic damage from climate change shows that the South Fork is in the top areas in the country, right up there with parts of California in terms of at-risk tax base due to sea level rise and more severe storms, all the result of warming oceans and atmosphere. We think it's vitally important that we complete as many of our objectives as soon as possible. We recently passed authorizing enabling legislation to participate in community choice aggregation. This would incentivize and allow our citizens to choose green energy solutions to supply their electric. We've moved forward with multiple electric charging stations to help make sure that there's infrastructure in place for the transition away from fossil fuels. We've also completed a 1.1 megawatt solar farm, which is the largest on the South Fork, and offsets about 50% of the municipal use town government buildings within the town. So to date, we've held 23 public meetings and work sessions discussing the offshore wind project with the in town, with both the town trustees and town board holding these meetings. We've engaged the public on many public meetings and discussions. And I think this will also add to that very large portfolio of discussions tonight. And I'm very pleased that this is taking place. So once again, I appreciate very much being invited to highlight some of the accomplishments that East Hampton has achieved towards energy renewability, and look forward to hearing the rest of tonight's panelists. Thank you very much.
Thank you so much. And it's great to see communities doing so much to take action on climate. We are hoping more localities will do the same. Before we move on, we want to do a quick poll, a 2-question, very brief poll, very easy, to get a little bit of information before we get into the panel. So I'll just give you just a moment to fill this out. Okay, thank you to everybody who participated in that poll. Next, we are going to hear from Jen Garvey from Ørsted, who will provide a project overview of the South Fork Wind Farm. Garvey is the New York Market Affairs Manager for Ørsted US Offshore Wind. In her role, Jennifer is responsible for local government relations and stakeholder engagement for Ørsted's offshore wind project serving New York. She's been working on the South Fork Wind project since 2017. Welcome to you, Jen.
Good evening, and thank you, Julie. Good evening, everyone. It's such a pleasure to be here. It's really terrific to have this opportunity, and we thank you for tuning in. Especially excellent to see so many attendees. So I do want to thank the League of Conservation Voters for hosting this forum together with its sponsors, its co-sponsors, the Group for the East End, Wind with Wind, and Renewable Energy Long Island. Also, many thanks, of course, to Joe Martens for moderating the questions that will be coming up shortly. And I'm going to be brief here with my opening remarks, my overview. I know we want to get right to the questions, but this presentation, as Julie mentioned, will focus on the onshore and nearshore impacts associated with this particular project, or those aspects of the project. And we really are prepared to get into the weeds with you today to answer your questions in a detailed fashion, and we have tremendous experts on hand to do that. So with that, let me go to the next slide, Lisa, if you wouldn't mind. And just hit some of the high points of the project, just to make sure we're all clear on what the South Fork Wind Farm is. New York's first offshore wind farms, obviously, and it is a project that's being developed by Ørsted and Eversource. Ørsted is the global leader in offshore wind and a renewable energy company. Eversource is New England's largest energy provider and a premier builder of transmission systems. It also has a 100-year history working in the Northeast. And as the slide shows here, the turbines that we'll be building as part of the South Fork Wind Farm are located quite far away, more than 30 miles east of Montauk Point. And so for the project area that we're talking about today, which is primarily in the community of Wainscott and easternmost parts of East Hampton, we're really talking about a project, the generation aspect being 60 miles away, which is quite far, very, very far, certainly not visible from shore. This is a project that will have no more than 15 turbines. It will deliver a maximum of 132 megawatts of power to the East Hampton substation. And as Julie mentioned, this is a project for LIPA. This was a project that was awarded through an RFP a few years ago. Our contract was actually awarded in 2011 to address a particular energy supply need here on the South Fork. And the project will deliver enough power for about 70,000 homes every year. The project is currently on track to become operational in December of 2023. And it is being permitted through two major processes. We go through a permitting exercise at the state level known as Article 7, which is led by the Public Service Commission. We also have a permitting process at the federal level. It's led by the Bureau of Ocean Energy Management, and that goes through the NEPA review, or the National Environmental Policy Act. So two major permitting processes, more than 10 major agencies weighing in on the different consultations, approvals, permits. It's a very robust and lengthy process. We did file our applications back in 2018. So we're quite far along at this point, and did reach some major milestones this year, particularly with respect to the Article 7 process, which is focuses primarily on what's happening onshore and in the waters in New York State. We have more than nearly 200 conditions that have been negotiated as part of that process that we'll need to adhere to when we're building our project, and that will be folded into the design of our project, all designed to make sure that this project is really a tremendous success and mitigates environmental impacts to the greatest extent possible, and minimizes community impacts as well. If we can go to the next slide. And so this evening we'll really be focusing on what's happening, obviously, on the nearshore area and the onshore area, the project footprint, if you will. And so there's three major work areas that we'll be talking about. The first is the sea to shore transition, which is effectively where the submarine cable that carries power from the wind farm to shore will come ashore. It's occasionally spoken about as a cable landing, for example, and that will occur under Wainscott Beach. So we'll be talking about that particular work area and the methodology that will be used. It's horizontal directional drilling, which allows for us to install that cable or set the cable deep under the beach in a very precise fashion that avoids impacts to the beach or disturbance of the beach of any type. The second work area that we'll be talking about is the underground transmission line. This entire installation will be underground from where it comes ashore at Wainscott Beach all the way to the substation facilities. And so we'll be talking about that particular work area and what you can expect there, a little bit of detail on what will be underground. And finally, we'll be talking about the interconnection facilities, the third major work area. This is where the power from the wind farm will first arrive at a new set of interconnection facilities or a substation. It will step down in its voltage. For those of you who know about voltage, from 138 kV down to 69 kV, which is the voltage of the existing that runs on the existing grid, and it will connect into the East Hampton substation. I'll emphasize that we are required through our contract to deliver our power to the East Hampton substation. And if you'll go to the next slide. This is just an overview of the route. So this, is the full project area that we'll be talking about this evening, and you get certainly a bird's eye view of what it looks like. It's about 4.3 miles in length, and you can see here the local roads that it follows. As I mentioned, it will come under the beach at Wainscott Beach. And then it will follow several town roads for about 2 miles. That's Beach Lane up to Wainscott Main Street, to Sayers Path, Wainscott Stone Road, and then Wainscott Northwest Road. It's about 2 miles in town roads, and then it will make that 90-degree turn into the Long Island Railroad corridor, which of course is state-owned, and follow that for about another 2 miles. The substation is directly adjacent to the Long Island Railroad corridor there. So, and with that, I'll conclude. I said I'd be brief. I know we want to get into the questions, and as I mentioned, we have really terrific experts to walk through your questions. So I'll hand it off. Thank you so much.
Great, thank you, Jen. Appreciate that overview to start us off. As Jen mentioned, we're now going to move into the Q&A portion of the program led by Joe Martens. Joe is the director of the New York Offshore Wind Alliance, a coalition of business, labor, and environmental organizations committed to promoting the development of offshore wind energy off New York's coast. Prior to that, he served as commissioner of the State Department of Environmental Conservation, where conveniently I worked as well, and was a senior fellow at the Open Space Institute, a regional land conservation organization that has protected thousands of acres of land from Maine to Georgia. Joe, over to you.
Thank you very much, Julie. It is a pleasure to be with you again. And it was a distinct pleasure to work with you at DEC. So we're going to launch right into it tonight. I want to introduce the two gentlemen that are going to answer all my questions and yours. We are very lucky tonight to have with us two experts, and I'm going to read you their backgrounds, which are quite impressive, and keep in mind this is an abbreviated version of their backgrounds. They both have long and deep experience in the electrical generation industry. And I want to first introduce Ken Bowes, who is the Vice President for Siting and Permitting for Offshore Wind at Eversource. Ken joined Eversource in 1984. And he held numerous leadership positions over his 36-year career there, including Director of Transmission and Distribution Maintenance, Director of Transmission Construction, Test and Maintenance, Vice President of Energy Delivery, and Vice President of ISO Policy, Siting and Compliance. He holds a bachelor's degree and a master's degree in electrical engineering, the latter from our own RPI University up in Troy, New York. Secondly, we have with us Dr. William Bailey, who is a leading expert on the potential impacts of electromagnetic fields on the environment and health. He specializes in applying state-of-the-art assessment methods to environmental and occupational exposure. He has 30 years of experience in laboratory and epidemiological research, health risk assessment, and comprehensive exposure analysis. Dr. Bailey was formerly the head of the Laboratory of Neuropharmacology and Environmental Toxicology at the New York State Institute for Basic Research, and an assistant professor and NIH postdoctoral fellow in neurochemistry at the Rockefeller Institute in New York. So welcome to both Ken and Dr. Bailey. And I'm going to try to pick up, Ken, with you first on where Jen left off. She identified three distinct work zones that will be of, I think, most interest to participants, residents of the east end of Long Island and others. They're the sea to shore transition area, which includes the workspace to perform the horizontal, we call horizontal directional drilling, which I know you'll describe to our listeners, which goes under the beach and into the nearshore area. Then we have the onshore transmission route, which, as Jen described, is about a 4-mile long line across town roads and into the Long Island Railroad corridor, all of which will be buried underground. And then there's the interconnection facilities at the East Hampton substation, located off Cove Hollow Road. So let's start with the sea to shore transition area. And Ken, could you describe what this process entails and how deep under the beach this process allows you to set the cables? And I want to emphasize that and appreciate the participants who sent in questions about each of these topics in advance, because it allowed us to, and allowed Ken really, to put together some slides that are illustrative of the questions you were interested in. So turn it over to you now, Ken.
Thanks, Joe, and thanks for the kind words in the introduction. It truly is a pleasure to sit on a panel with Dr. Bailey as well. He's clearly one of the world's experts in this area and can answer the very detailed and scientific questions that will have been posed, and maybe additional questions as well. Yep. So the first thing I'd say about this figure, it's not meant to be to scale, and it's made to be illustrative of how the process would work. And we're going to get into more factual type actual diagrams with a couple of the other pictures that are coming up. But this really gives a sense of what's impacted specifically to the beach and the dune area. In this case, we've agreed to a certificate condition with the New York DEC to move back the drilling operation at least 500 feet from the beach. So our work zone on Beach Lane is going to start about 550 feet from the pavement at the end of Beach Lane. So we are quite a ways back from the actual beach location. There's an open field there for people that are familiar with Beach Lane. We're going to be adjacent to that open field to the east side of Beach Lane. In this case, the drill rig and equipment will be set up in a longitudinal fashion, taking up one of the lanes of Beach Lane, which we're going to have more diagrams on. And this allows for a smooth trajectory to enter into the earth, go down under the roadway, under the beach, and then out into the water. And the distance out into the water is about 1,750 feet. So as Jen mentioned before, the total operation here is about 2,500 feet, or almost half a mile in length. So we are not going to be close to the near shore water activities. We're going to be well under the existing Wainscott Beach. In fact, some of the recent publicity that's been gathered for a large offshore vessel that was doing geotechnical sampling in the nearshore waters is really to inform this final design. And ultimately, there will be a final design drawing for this, and it will be published as part of the second phase of the Article 7 process. People can review it. And I think, the town, the trustees, and the local residents will be very pleased with the depth that we're able to achieve. Now, this is a minimum of 30 feet. That's what we've agreed to. We're hopeful that based on the geotech sampling we've just done, that we can extend that much deeper. Now, why is that important? Obviously, this is a very dynamic beach environment, very dynamic offshore conditions here. In fact, people that have been on the beach recently have seen a 4 to 6 foot drop in the sand, based on I would say by no means a major storm in the area. So what we've done to inform this is look back over the course of several decades, in fact, back as far as we could find records of how the beach has eroded both seasonally and after extreme weather events. We anticipate the events in the future will be more extreme than they have been in the past. And that's why the 30 feet, I think, is a very good bellwether to what will happen in the future. Also, the 500 feet from the existing, 550 feet from the end of the parking lot is also a good bellwether. We believe that the beach erosion will continue. We believe that by 2050, which the project will still be in operation at that point, that location of where our transition vault is and where the drilling path is will be much closer to the water than it is today. And obviously there's a lot of human impacts that go with that. There's many residences that are between where we are drilling and the open water today. Those probably will see impacts over the next 3 decades.
Got it. And Ken, I want to stick with this for a moment because I know there has been a lot of concern about the potential for these cables to either resurface or become exposed over time. And there was, I know you're very familiar with the situation for the Block Island wind farm, which was the first wind farm, a little pilot project off the coast of Block Island, Rhode Island, where the cables did resurface. And I wonder if you could talk about the differences between how those cables were buried and how the cables will be buried here.
Sure, there's 2 main methods to transition from the open water to mainland. One is called an open cut, where it's exactly as it sounds. You basically trench along, in this case, the beach. You dig down as deep as physically possible, and you place the cables in that trench and then rebury it. That is certainly a worthwhile and a suitable construction method. In fact, Eversource just completed a project using an open cut method in Little Bay in New Hampshire. We also just completed a project similar to this in Boston Harbor, where we used horizontal directional drill. And the real difference is based upon how dynamic the environment is. If you go deep enough, open cut is certainly fine. In the case for Block Island, I think that the depth was 10 feet. So for example, if just what I mentioned before, if you've lost 4 to 6 feet in a kind of a small storm event or a couple storm events, now you've only got 4 or 5 feet of cover. Clearly, that's not going to be suitable for an environment like Wainscott Beach. Wainscott Beach, you're going to have to go fairly deep in order to achieve not only the seasonal variations you see, but from a major storm event, which, as I say, in the next 30 years, there'll be 1 or more of those events that will have significant impacts to the beach. By going deep enough, you eliminate that possibility of cable exposure, and going far enough as well. So again, if you're thinking about the open cut method, you're going to be right in the water, as you come onshore. In this case, we're more than 1,700 feet offshore into an environment, again, that we've studied that has shown dynamic environment. I'll certainly grant you that, but nowhere near as dynamic as what you see on the shore itself.
Got it. Thank you, Ken. So tell us a little bit more about the HDD process. What does the equipment setup look like? How long is it going to take? And I see you have a very detailed diagram there, but walk us through that.
So this is a diagram actually from our Article 7 application, and it's publicly available. It's been used at various points during the public process and the hearings as well. This is not the final design. I will just say that, but it is very illustrative of what will be there. There's a series of tractor trailer mounted equipment that we placed along, in this case. Now we've kind of inverted the slide here. So this is now towards the east side of Beach Lane. Again, the work zone starts about 550 feet back from the paved area of the parking lot, and then goes along in a linear fashion. And there's a variety of equipment that's placed in here. The drill rig is just part of that. There are also tanks there to separate the drilling fluid and then reuse it. Remember, everything that comes out of this hole, and again, the hole is going to be about 2,500 feet long and about 24 inches in diameter ultimately. So there's going to be a lot of material that comes out of that hole. That has to be carted away, disposed of properly. And the drilling fluid we use is both to cool the head of the horizontal directional drill, which is guided by a global positioning system or GPS system. So the precision is very high as where we, both enter the ground and as we exit in the exit pit out in the water. I've seen installations where we've done similar 2,500 foot, HDD, horizontal directional drills, where the end result was within 1 to 2 feet of where we predicted it to be. So there's a high degree of precision here of where we're going to exit into the water.
Mhm.
The other types of equipment here are the casings that will be used, at least for the first few 100 feet of the drilling, and all the other materials that are needed to do that drilling operation. So there's materials and supplies along this corridor. The other thing that's important to see here is that it's a fairly narrow road right of way here, called a 3-rod road, or which means it's 49.5 feet in width, and we're going to take up, a good portion of that. But we are going to maintain access during the entire operation, which is again to the west side of Beach Lane. There may be some temporary access roads added there. There may be some gravel added as some fill. But once we've, completed this work, there will be full restoration. So beach access will be maintained both for vehicles and for people during the entire operation of the horizontal directional drill.
And Ken, how long will that take roughly, do you think?
So we've agreed to some work window restrictions, which basically lets us start in October 1st of a year and finish by April 30th of a year. So that's several months, obviously in duration. I would anticipate that it'll take us a few weeks to set up this work site, and included in that is a sound wall that will be added around the equipment to minimize the impacts of sound. And then on or about November 1st, we will start the drilling operation. The drilling operation will be conducted from about 7 a.m. to 7 p.m. up to 6 days per week. So we're not drilling 24 hours a day, and we're not drilling on Sundays. Now, if you start looking at that time frame from November 1st, it's probably about 2 to 3 months in duration to complete that work. However, we do anticipate there will be weather events that we deal with, and obviously there are holiday periods in this time frame, Thanksgiving and Christmas to New Year's. Those periods of time, there's probably going to be less work performed for this. So in that case, it's not a, say 2 months straight duration. It's probably going to be a little bit longer. So we would anticipate, if things go well, and again, when I say things go well, the first bore is done, the second bore, the third bore, because increasingly we go up in size from a pilot hole that's a few inches in diameter, ultimately to a finished product that's more than 30 inches in diameter. That process will evolve over that 2 to 3 months time frame. And then the last part of the project, or the process for the HDD, is actually pulling in a plastic sleeve, 24 inches in diameter. And how that is done is it's done from the sea to the shore. So we'll be floating out sections of plastic pipe that have been welded together, and that will be submerged and then pulled back in through that borehole with the same drilling rig that we see here. And then that will be the finished product of the horizontal directional drill.
And you mentioned noise, Ken. This is obviously some significant equipment and a sound wall. How would you describe, as best you can, the noise impacts and how they're going to be mitigated?
So the sound wall will certainly alleviate, a lot of the high frequency as well as some of the low frequency noise that comes off this equipment. We're also trying to strategically locate the equipment. In this case, you see some of these devices side by side. So the equipment itself acts as a buffer to, dampen the sound levels.
Mm-hmm.
We have time of day restrictions around this as well. Again, not starting before 7 a.m. and finishing, prior to 7 p.m. and not working on the Sundays. We also will have an environmental inspector on site, and they will be able to access the real-time sound level monitoring that we've agreed to with the town of East Hampton. So we can tell, on a real-time basis how the noise levels are at this location. And things can be modified based upon, the sound levels we see.
So you're hopeful, and I want to let you characterize it in your own words, that the work could be completed in one season.
Yes.
And how confident are you of that?
So when you say work completed in one season, the actual HDD
And that's what I'm
billing
referring to,
operation,
right?
because there's several other
Yep.
sequences of work here.
Right.
But the actual HDD, I am very confident that we can complete that in one season. And that again is from November 1st and well prior to the April 30th timeline.
Gotcha. And could you describe how the submarine cable then connects to the rest of the onshore underground infrastructure? I think that's the next sort of leg of this, that of the work that you were just describing.
Well, that's why I was very careful to articulate that it was just the HDD work that I was discussing.
Yep.
So there's two sequences of work that happen before the HDD and one major sequence that happens after the HDD. Before the HDD work, you saw that long longitudinal work zone. Well, the existing overhead distribution lines that are there and communication lines will have to be buried. So that will probably happen the season before, at least one season before we actually start the HDD work. We will also place the vault where the submarine cable comes onshore and the duct bank where the work zone is entailed prior to doing the HDD work. So that in itself is 1 to 2 months of work that will happen in a different sequence than that fall work that I was talking about. Right now, it appears that we will get our last federal permit in January of 2022. About a year from now, actually a year and a week from now, that will allow us to do some of that pre-construction work, pre-HDD work. Shouldn't say pre-construction because it's clearly construction work of placing this vault and placing the duct bank in Beach Lane prior to the fall of 2022, where the HDD work would commence. So two sequences of work here. One, it's 1 to 2 months prior to the HDD, and then the HDD between that October 1st and I think well before the April 30th deadline.
And could you just describe for the listeners what the purpose is of the vault?
Yeah.
You have a picture of it here, or at least the construction.
Yeah, this is what you're seeing now is a top of a vault.
Yep.
And again, it's a fairly large underground structure made from sections of concrete. So a concrete wall, concrete floor, concrete roof, and then there'll be 2 manhole covers. This is buried into Beach Lane about 550 feet or even a little bit further back from the edge of pavement at the end of Beach Lane. So you're back now several hundred feet. This will be buried in there. And this is where the transition takes place between a submarine cable, which is about a 12-inch diameter bundled cable, which has 3 conductors, each insulated at 138 or 438 kV, and 2 fiber optic cables for communications and protection and control. They also allow for temperature monitoring, the fiber does.
Yeah.
So from there, we go into 3 separate cables that are about 4 inches in diameter. So the onshore cable is different than the submarine cable. So this is where we take that transition and take a 3 conductor, 3 cables in one bundle and separate it into 3 separate cables with a special splice that is designed to do that. We'll also be splicing the fiber optic cable here too, because the onshore fiber optic cable is different than what's embedded into that cable bundle for the offshore. That process of splicing takes, again, it has to be a climate controlled atmosphere, almost like a clean room. So they'll be placing plastic inside this concrete vault. They will be placing air handling equipment to both filter the air as well as condition the air to a certain temperature and humidity. And that will take several days to set that equipment up and create an environment that is clean room-like, operating room-like, because we need to make sure that no contaminants are into that cable splice. The manufacturing processes at both factories for the submarine cable as well as the onshore cable are very pristine conditions. But now you're in a field condition where we have to make sure that no contaminants enter the splice, and therefore the extra precautions are taken to do this. So this process is 1 to 2 weeks as well.
Got it. Thank you, Ken. So that brings us right to work area 2. We're leaving the offshore to onshore area now. And this is the onshore transmission route where the duct bank or underground cable infrastructure is installed in the local roads and in the Long Island Railroad corridor. So can you take us through that process, how long it'll take, and just describe again how you will stage that work?
Yeah. So as the first part of this process is we actually install vaults like the one in the previous picture, but a little bit smaller because the splices themselves are physically smaller for the onshore cable. So these vaults are about 26 feet long by 10 by 8. So still like a large minibus being buried. So those are about every 2,000 feet. Our initial design shows that we're going to be using 10 of those along the route, which includes the 2 miles of town roads and the 2 miles along the LIRR. So about 6 vaults in the town roads and then 4 along that straight shot section to the substation on Cove Hollow. So those are placed first. Each one of those vaults takes about a week to install. So 10 weeks of work if we use 1 crew, 5 weeks of work if we use 2 crews. Then we connect between those vaults, between the transition vault on Beach Lane to the first vault, and then from there on, all the way to the substation. Those are done in this concrete encased conduit system. And so a trench is dug with a trench box, probably about 4 feet in width, the trench box, and we'll dig inside of that. We'll go down the path. We may have to do temporary shoring, as you see in the picture here, using either plywood or actually lumber to do that. And that's because of the soil conditions on Beach Lane are very sandy. So it's not a stable environment. We anticipate the digging will be relatively easy going along here. There's no visible ledge. We're doing geotechnical work right now on Beach Lane and at every vault location, as well as about every 500 feet along the town roads. That will inform both the type of materials we're going to encounter, the soil conditions, and also how well the adhesive ability of that soil. But I'm anticipating that we'll have to do shoring along the entire route just because of the nature of it. So there's 3 power conductors at this point. So there'll be 3 larger conduits, followed by 2 conduits, 1 each for each fiber optic cable. And then there'll be 2 grounding conduits as well. We run a ground conductor adjacent to those power conductors. So in total, 8 conduits, 2 of them, or I should say 4 of them, 2-inch PVC, 3 of them, 6-inch PVC. So again, similar to the gray conduits that you've seen, either utility grade conduits that you use. Once those are the trench is dug, we'll be installing the conduits, seaming each conduit so they fuse together, and then going along at a pace of about 100 feet per day. So if you start doing some math there, 2 miles, 5,280 feet per mile, start a little over 10,500 feet, start doing some math, 120 days plus or minus of work to do this duct bank system in the town roads and a similar amount on the Long Island Railroad. Long Island Railroad does have some additional complexities though, because of the much tighter work zone than we have on these town roads. So one crew would complete the duct bank work in about 120 days. If we see issues with production, we could add a second crew, or based upon the work restrictions we have for the town roads, which again are from from October 1st to April 30th, we might have two crews on the project, but focus them solely on town roads to start in that work window, and then transition to the Long Island Railroad where we don't have the same restrictions for that time period where, more the spring and fall months. Why we have the restriction with the town of East Hampton for this work? It's really to deal with the summertime traffic. Although some would say that the traffic is increased now much more than say normal in the off season, because of the pandemic issues, people staying in the Hamptons more. But we're clearly focused on trying to minimize the traffic impacts from this work. Because as you can see here, we do take up approximately one lane of traffic while this work is ongoing. The length of this work zone is much shorter than the HDD work zone, about half the length. So this from start to finish is about a 300-foot work zone that will move along each day at about 100 feet per day. So say a person has a large residence in East Hampton, we're very typical. Say you have 300 feet of road frontage. So you're going to be impacted starting for 3 days prior to getting in front of your house, 3 days while we're in front of your house, and then 3 days after we're past your house. So that could be 7 to 9 days of impact for residents with a 300-foot frontage. And you can do the math accordingly, either higher or lower, based upon those numbers.
And Ken, when you say, we'll have impacts, are you talking about one-way traffic with
Yes.
Staff at both ends to allow traffic to go for, again, possibly a 300-foot length at a time?
Correct.
Yep.
So as we enter through the work zone, a question that often comes up, not just in this project, but in many projects. What if you're digging in front of my driveway and there's an emergency? What happens?
Yep.
Well, the crews have a metal plate that's available to cover the section of the driveway. We try to do half of the driveway at each time. So over the course, we would stop there. And then the plate is always available there to make sure there's always access to every residence along this path.
And emergency vehicles.
And emergency vehicles, correct.
Right. So tell me, how quickly do these areas get buttoned up, and what will they look like on a, temporary, and then what happens at the end of the project?
Yeah, so this is clearly a before and after simulation. And I would say there's a lot in between here. So ultimately, the project will leave the area better than we found it. But during that process, there's an existing view and a post view. We will pave the entire roadway, but before we do that, we're going to put temporary patch in for that time period. And then we'll pave the road in its entirety when the entire project along this road is completed. What you're seeing here on the right-hand side is actually where a splice vault would be located underneath the roadway. So that's what will be visible when we're all done. Is a single splice vault will have 2 manhole covers separated by about 20 feet apart. Why 2 and not 1? Simply for worker safety when they do have to access the vault and during the splicing operations. We want to make sure there's a place to add clean air into the vault. It is a defined enclosed space. And we have to make sure that there's entry and exit for the workers as they work in that, doing the splicing operation. Obviously, restoration will take place. We have some certificate conditions around that, and it's a phased approach. So if we finish work on Beach Lane, we restore Beach Lane. The only constraint I would say there is that with asphalt plants being open seasonally, we may have some work windows where we have to wait until the asphalt open And that's happening, seems to be happening, unfortunately, earlier and earlier in the season every year. But in the March timeframe, April timeframe, the asphalt plants are typically open now.
Right. So overall, before we get to kind of the third phase where you're connecting to the East Hampton substation, how do you describe sort of the overall before and after conditions for the project as a whole? What will people see from the beach, from the town roads? You know, what is going to be visible to them? Because visibility is always a big issue with any big construction project. People want to know what they're going to be looking at.
Yeah. So for the sea to shore transition, Beach Lane, this is actually, you know, a simulation of Beach Lane, where we've relocated the, you know, existing electric facilities underground for a small portion of Beach Lane. They won't see the overhead. They'll have a new road paved, and there really won't be any permanent impacts other than, you know, the manhole covers, 2 covers every 2,000 feet. There are impacts, obviously, to the neighbors adjacent to the Long Island Railroad, which we really haven't talked much about yet, and their impacts to, you know, the expansion of what's that East Hampton facility, what we call an interconnecting facility, but it's really a new substation adjacent to the existing uses there, which include a substation, a battery storage unit, a permanent peaker generation unit, and several temporary generators are installed at the East Hampton substation. We are going to be expanding that substation. I think you have a slide coming up on that as well.
Yeah, why don't we go to that? That is the last, you know, kind of the piece of this project where you're connecting to the substation. So walk us through, you know, what activities will be going on at the substation when you get there, and again, what the, you know, you anticipate as any likely impacts to people that are living near the substation.
Yeah. So this is again a graphic from the Article 7 filing. There have been many changes to it since this was filed, and I'll talk through some of those. And some of those are directly related to the town of East Hampton conditions that they have asked for, and we've agreed to. Yeah. So we're looking for about a 2-acre parcel of land adjacent to the East Hampton substation. We've found one on a piece of National Grid property. It's adjacent to their existing peaker unit. Here it is right here. Mm-hmm. And we are looking to stay within a scenic easement. So National Grid has a scenic easement around the border of this to protect the adjacent residential properties. This is a zone commercial area. Its historic use has been for, you know, utility infrastructure. We're going to be placing our facility in approximately the location it shows here. It's actually going to be a little bit smaller than this shows. Again, one of the changes we've made through the process we used, you know, discussions with the town, have been to both lower the structures from what was originally 65 feet to around 45 feet. And we've also agreed to include a permanent wall around our facility, both for aesthetics, for sound levels, and also for security. So all 3 of those things we've agreed to by you know, providing this sound wall, and that also requires a town ordinance exception. The height one was 1, you know, over 35 feet in the town of East Hampton, you have to seek an ordinance exception. And for the sound wall that we're putting up, it's over 10 feet, which also requires an exception. We think it's going to be approximately 12 feet in height. So again, we've agreed to work with the town on the architectural design of the wall, as well as a landscaping plan that would be, you know, replanting around the substation to again provide some visual blocking of the substation itself.
Ken, it looks like there's vegetation around there existing. What's the nature of the vegetation that's already there?
Yeah, I would say it's you know, typical vegetation. There's nothing to say extraordinary about it. It's not Sherwood Forest, let's say. It's kind of scrap, you know, a lot of scrap type. You know, I would say it's not again, it's not high quality vegetation, I would say. I'm not putting that down. I'm just saying that, you know, it's not a, you know, it's an industrial site.
Yep.
Let's just be honest. It's a large
So-
generator that's been there for, you know, 50 or 60 years. We are getting closer to, you know, a couple of residences. They have expressed concerns. You know, we've listened to those concerns, and that's part of the reason for the sound wall as well, and visual blocking of it.
Mhm.
We're still going to be kind of a, you know, we're not going to be the dominant feature in the visual impacts. And from most adjacent landowners, you're not going to be able to see our facility.
And tell the audience what the time frame is for the work on this facility.
Yeah, so this is actually the longest duration of the construction activities. I mentioned that we think we'll get our final permits in January of 2022. We will begin work on the substation soon after that. There are several work window restrictions we have. In the case for the substation, it's for a threatened and endangered species. The northern long-eared bat has the potential to have nesting grounds in and around that facility. So we will do surveys, and then we'll have, you know, work restrictions about when we can actually do the vegetative clearing for that substation. One of those work windows that they don't do nesting is in that early spring timeframe, up until the end of February. So this work could continue or could commence actually as the first part of work done on the project is actually at the substation in that February timeframe, and then continuing on for up to 18 months for that work to happen, including the final commissioning. Again, after we do all the onshore work that we've talked about, we still have the offshore work to integrate into that. And that takes actually several months of testing and commissioning for the offshore wind farm to be interconnected safely to the onshore facilities. So you see here the other durations we talked about again.
Yeah.
The HDD from that October setup, November start, and commence or cease by the end of April. And then the onshore underground construction as well. About 9 months in duration, and it includes both the segments and the town roads, as well as along the LIRR. So those people along the LIRR, I mentioned that a little bit previously, is they are going to see some activity that is more, I would say, steady than the occasional train that goes by. So we're going to be out there, again, going about 100 feet per day. But again, this is a very narrow work zone.
Yep.
So there's room for basically one vehicle and to maintain a safe distance from the tracks. So it's going to be a linear type process where we have to excavate and fill a dump truck, exit, next dump truck comes in. So that process is going to be, you know, fairly slow as compared to working in the town roads.
Right.
We don't have the same seasonal restrictions for that, but we also have some challenges with actually performing work in a much tighter space.
Got it. Thanks, Ken. So we've actually had some questions about, you know, what are the impacts when the project is up and running, you know, during operation. Will there be any residual noise, for example, from any of the underground transmission lines?
The simple answer is no to you know, all of the export cable that comes up on the beach, all of the 4 miles to the substation. This is it's carrying electricity, but it doesn't make any sound. There's no audible noise that comes from it.
Right.
Unlike sometimes you'll hear audible noise coming from an overhead transmission line. None of that is apparent because of the construction of the type of makeup and physical construction of the cables. They just don't emit any noise.
And how about people wonder with electrical cables in particular, whether there's any risk of fire?
Sure. So these are, again, a little bit different than what you see along the roadways. There's high-speed protection, and truly it is the speed of light. That's why the fiber optics are used. So we have a very long transmission line here. It's about 60 miles offshore, 4 miles onshore. So at the speed of light is how fast we will interrupt those circuits. And by interrupting them that fast, it's like a circuit breaker in your house. Rarely do you see any adverse impacts from that circuit breaker tripping. And it really is the same safety margins that are built into your house equipment are built into this equipment. The only difference is these operate even faster. So
yep.
Very, very, very low chance of any disruption based upon the underground transmission lines. And that's based upon, more than 30 years of experience now with this type of cable system. And the cable systems and the quality control of these cables only has improved over those 30 years. So
thanks, Ken. So Ken, before I jump over to Dr. Bailey, there was a question from the audience about the timeframes and both the 7 a.m. to 7 p.m. and the October through April. How are they going to be enforced, and what happens if you don't abide by them?
So simple answer is we're going to hire contractors to do this work, so they're going to have contract oversight. We, as the South Fork Wind, will have oversight on that as well, and we're going to have independent inspectors, both for construction, for safety, and for environmental. Any person on the work crew or any of the inspectors can shut down the job based upon their focused area of expertise. If they see something that's unsafe, we want them to stop the job. If we see something that's in violation of the environmental regulations that we have, we want them to stop the job. I've always found that although shutting down a job rarely happens, when it does, it's always been warranted. So I would encourage that, and ultimately we're under the watchful eye of many people, and we anticipate that the town will be observing our work, especially as we're in their roadways, so they'll have oversight. We expect that the state of New York will have oversight, both from the DEC, from the DPS, and we expect there'll be federal inspectors as well that come onto this job site, and we welcome them. And we want to make sure that we are open to any criticism that comes up, whether it's warranted or not. We will take that. We'll try to do better. So,
great, thank you, Ken. So I had intended to go to the audience questions at the end, but they're coming in fast and furious. So I thought I'd ask one more again before Dr. Bailey talks about electromagnetic fields. The question is, I think, an important one to the community. Will Wainscott be able to enjoy our beach during the planned work?
The simple answer is yes. It will be a little bit different than it is today. I mean,
Yep.
it's basically, unfettered access, people, walking with strollers down to the beach, people walking their dogs down there, people driving to and from. I mean, there's no doubt that during that 4 or 5 months, when there's a single lane available, that is constriction. That is going to be a limitation on what it versus it is today.
Yep.
But again, it's typically going to be the single season, and it's going to be over quickly, and it's going to be left as well or better than we found it.
Yep. And on the beach, I presume they won't even be aware that there is drilling going on 60 feet or 30 feet underneath the beach surface.
That is correct.
They will hear the construction activity from behind, but underneath the beach, they will be able to walk
And
around
obviously,
the beach.
yeah, yes, that's true. There will definitely be construction, noise, with a sound wall, but on the beach, I doubt you're going to hear that. Like I say, Wainscott Beach, I mean, it not only has a $1 million view, it's got $1 million sound.
Yep.
I mean, it really does.
Yep.
It's just a fantastic place. And I understand why people are so protective of it.
Mm-hmm.
But it also is, the ambient noise from the surf is fairly loud as well.
Right. So in the interest of time, Ken, thank you very much. And we may come back to you with questions if time permits at the end, but thanks again for your, very thoughtful and in-depth answers. And I want to go now to Dr. Bailey, who, as I described earlier, for those who may have joined us a little bit late, Dr. Bailey is one of the foremost experts, I would say, in the world on electromagnetic radiation and electromagnetic fields. And I think there has been a lot of concern expressed about the potential for EMF impacts. And to just put it in very direct terms, folks have asked, could it harm people? Could it harm pets? Could it harm marine life? And Dr. Bailey, you know more about this than probably anyone. So I'd like to you describe in your own words what you anticipate the impacts from EMF would be from all of the underground transmission cables that will be installed at this in and around this site. I think you're still muted, Dr. Bailey, and I don't see your screen.
You can hear me now?
We can hear you now, loud and clear.
Okay. As part of this project, we were asked to evaluate the research literature on electric and magnetic fields to assess the exposures that were related both to fields coming from the subsea cables, but also the underground cables on land. That process is reviewed, as Mr. Bose indicated, on land, primarily by the state of New York, and in the subsea portion by federal and state agencies looking at potential impacts to the aquatic environment. The cables that come ashore, as Ken described, come in well under the beach at great depth, and then continue in trenches underneath roadways. These cables are insulated. All electricity is capable of producing both electric and magnetic fields. The electric field is related to the voltage, and that field is totally blocked both in the submarine portion and the ground portion by the metallic shielding around the cables. So the electric field that is present from overhead power lines is not a feature of this underground construction. The other thing that you can see here is the configuration of the cables, both onshore and also offshore. So let's look at the left-hand figure, which is showing the bundled submarine cable with the 3 individual conductors. And magnetic fields, unlike many other things we measure in environment, like levels of oxygen or CO2, they have not only a magnitude, but a direction. And so each of those conductors is the source of magnetic fields, but when you place them very close together, the magnetic fields coming towards each other can partially cancel out the magnetic field from the other cables. So a big difference from an overhead power line, where for reasons of electrical isolation, you have to have the conductors spaced far enough apart so you can't have any kind of flashover. Here, when you place them in the submarine cable configuration, the cables are insulated from one another, and so they can be placed very close to each other. This close placement of the cables allows the magnetic field from each cable to partially block the fields coming from the other cables, and so you have very, very low magnetic fields around these cables. Now that's the submarine portion. Now, if you go to the right-hand figure, you see that the cables are placed in the underground duct bank, and they're slightly further apart. But again, in this underground configuration, the cables are placed very close together so that the fields tend to cancel one another. So the first thing to note about both of these configurations is this close placement allows the fields to be very low in the ground above the cables. These magnetic fields above the cables will be below the limits that are set by the state of New York on the construction of new transmission lines, and also, more importantly, below the international safety standards that have been set by 2 organizations and are recommended by the World Health Organization. So directly over the cable, if you were standing over it, the fields would be 10 to 50 times below the lowest of those international guidelines. And when you get further away off the street or at a residence or on the lawn or at the beach, the fields would be 500 to thousands of times below those guideline levels. So that, as Ken explained, the cables are well designed and insulated to address issues of shock, and the design also results in very low levels of magnetic fields above ground and no electric fields. So the installation in the town of East Hampton will be very much like it is in other towns and cities that have underground cables under the streets and roadways.
So thanks for that, Dr. Bailey. So try to put it in context for us about the amount of EMF here compared to everyday household appliances and the like. And give us some easy to understand comparisons if you can.
Sure. Well, as every thing that conducts or uses or produces electricity will be a source of electric and magnetic fields. And for magnetic fields, the fields from the cables at the edge of the roadway will be very similar to what we have from the overhead distribution lines that exist today and are found in most every community. The magnetic fields, people are often surprised that the exposures to magnetic fields in people's homes are dominated not by outside sources, but by sources within the home. That is the wiring within the home, and particularly close to appliances. So here you can have fields that could be dozens to hundreds, or sometimes for some appliances, even thousands of times higher than what the fields would be coming from this project. Various national and international agencies have looked at the research on electric and magnetic fields and have not found any persuasive evidence that at the levels that we find in our daily environments, or certainly associated with this project, would be harmful to health or the environment.
So I have thank you for that. And I have a question from the audience, which I don't understand, and perhaps you will. The question is, South Fork Wind complying with any EMF standard other than those issued in 1978 and 1992? Is that?
The standards that are referenced in 1978 and 1992 are the standards that the state of New York set for the permitting of new transmission lines, whether they were overhead or underground, and those requirements were set to make sure that the any new transmission lines that were constructed in the state of New York would not have levels that were higher than existing transmission lines that had been accepted for many years. As I mentioned, the project would comply with those limits, and they also comply with health-based limits that are recommended by the WHO, the International Commission on Non-Ionizing Radiation Protection, and the International Committee for Electromagnetic Safety. So those are the standards that comply. In addition, the National Electric Safety Code develops standards for the construction and operation of power lines that further ensure electrical safety.
Thank you, Doctor. So I have another question from the audience about whether or not there has been any type of literature review that you're aware of about the that has looked at East Coast fisheries species specifically, both recreational and commercial, and whether EMF, has any impacts on East Coast fisheries, fish species rather.
First of all, we and other scientists were involved in a major literature review for the Bureau of Ocean Energy Management to assess electric and magnetic fields from submarine cable sources in U.S. waters.
Mm-hmm.
And as part of that, there was an investigation of the interactions of electric and magnetic fields from submarine cables with many marine species that inhabit the waters on the East Coast, as well as those inhabiting waters on the West Coast. Furthermore, and more recently, as part of this project, our biologists conducted a major review and assessment of species found in the project area, their likely susceptibility to be able to detect and react to electric and magnetic fields, and how their sensitivity for those species compared to the fields that are expected during operation of the submarine cables. In addition, we and other scientists were involved in a review more recently for the Bureau of Ocean Energy Management that specifically focused on marine species of recreational and commercial interest in the New England area to assess whether there was an expectation that there would be any adverse effects on these populations. Our own assessment and those of Bohm and other scientists are that the distribution and migration of species will not be affected by the proposed wind farm. And that is based upon both assessments of research conducted in laboratories and also field studies around existing submarine cables and also wind farm projects in Europe already operating. And of course, as we mentioned, the Block Island Wind Farm now operational in Rhode Island.
How are EMF readings monitored in a project like this?
For existing facilities, it's quite easy to take a magnetic field meter and directly measure the magnetic fields. Here, in looking at the fields that would be expected from a project that has not yet been constructed, we use the laws of physics to calculate what the electric and magnetic fields would be based upon the current that flows in the cable, the configuration of the cables, and the distance where you want to calculate the fields. And our experience has shown that these methods of calculating the fields are very accurate and can be confirmed quite easily after construction. And there is a plan as part of the permitting process in the state of New York for this project to carry out just such a post-construction monitoring plan to confirm that the expectations of the field levels as part of the application are in fact to be confirmed when the project is in operation.
Great. Thank you, Dr. Bailey. I'm mindful of the time. It's 7:23 and we've had lots and lots of questions come in. So I'd like to bring Ken back in so I can go through these, and I wish we could get to them all, and I think Julie will talk about how we'll try to get answers to these questions subsequent that we aren't able to get to tonight. But
I believe I'm back on, Joe. So
you are great, Ken. Thank you.
And one thing I would add to Mr. Bailey's comment is that we do have extensive monitoring requirements, both in the water, on the beach, and onshore for EMF post-construction, and we do have to comply with those New York State requirements. So that is a requirement.
Thank you. So I'm going to just start reading through some of the questions in rapid fire, and hopefully, the answers will be relatively short so we can get to as many as possible. I've asked, one of the attendees has asked for a clarification of whether the vaults and work zone will be on the east or west side of Beach Lane.
The transition vault will be on the east side of Beach Lane. I don't have the positions for the other 10 along the route. That will be forthcoming in the next couple months when we file the EM and CP,
Yep.
which is the final design for the project. So, and that will be available for public comment as well.
How often will workmen need to access the vault beneath Beach Lane?
So the two vaults on Beach Lane, the transition vault and the other vault, we'll do an inspection at a 1-year interval. Again, just to make sure the cables are racked properly. There's been no corrosion. We do use stainless steel as far as the supports in there, but it's a very harsh environment here. We could even have some mixed water in here with surf coming up onto the road. So we'll be looking for corrosion at 1 year. And then after that, it's a 5-year inspection cycle. So once every 5 years. And what does that mean? We would clean out the vaults. We would do a physical inspection, look for cracks on the concrete, make sure the cables are still racked properly on the walls. And that's, we would do both locations on Beach Lane in a single day. If we had to pump out the vaults because of water, that would be additional time as well, but fairly infrequent operations and maintenance activities.
Thank you, Ken. Another question, how long will it take? I assume the reader or the attendee means between Beach Lane and Route 27. Will this traverse Wainscott Stone Road at any point?
I don't believe so. I think we come onto Main Street, Stayers Path, and then I think Jen actually had the whole list of roads in one of the slides, one of her slides. So no, I don't believe we ever traverse that.
Okay. Who performs the HDD work? Is it Orsted staff or working with a specialist subcontractor?
So we've hired a company called Mott McDonald to perform the engineering analysis, and we probably will award the construction to them as well, based upon the work that they've done so far.
Got it.
They're a US-based company that specializes in this work.
Thank you. Could the welded plastic pipe leach any harmful chemicals into the environment?
I'm sorry, I think Jen just corrected me. I guess we are on that previous road for a short portion. So, and could you repeat that question, Joe?
Sure. It's could the welded plastic pipe and I assume they mean where the pipe connections are put together, leach any harmful chemicals into the environment?
Not based on the knowledge we have today. I mean, obviously it continues to evolve, but it's like a PVC or HDPE plastic, hard black plastic conduit. Will it deteriorate over time? Certainly not in the 30 years that we have for this project, but in the hundreds of years, it's potentially an issue to think about. And that would be part of our decommissioning plan that we're required to do. So this equipment does have to be removed at the end of the project.
I was going to ask you that, Ken. I think when we have had questions about decommissioning. So I think it's relatively safe to summarize that you're required to remove the project and all the infrastructure at the end of the project life.
So based on what I know today, I would say yes. 30 years from now, they may have found that it's better to leave certain aspects of the project intact than to remove it. It might have less environmental impact or less impact to fisheries. But as of today, we would plan to remove the wind farm, the foundations to 15 feet below surface, all of the cables, and then all of the Splice Vault and cables onshore, and remove the substation as well.
So I also want to just clarify something. I think there was early on in the presentation, it mentioned that the South Fork Wind contract was awarded in 2011. I think that was just an error. It was much later than that. I think it was when Ken was the contract awarded, was it 2017? Yeah,
I think this is part of the Reforming the Energy Vision of LIPA's plan that was approved in 2015. Then they went out to bid in 2016. I think the contract was awarded in 2017.
Right. Okay, thanks. We just wanted to clarify that. Let's see. I'm jumping around here. I think we've had a couple of, 7:29. I see Julie Ty.
I'm here, but actually, I'm going to ask a question if that's okay. Because I think this is one that a lot of people are interested in. One of the questions we have is why hasn't Atlantic Ave been considered as a cable landing location?
So it has been considered. The previous, group, Deepwater, did an extensive analysis of shore landings, including probably a dozen locations between Atlantic Avenue and Beach Lane. They looked at locations out to Hither Hills. They actually looked at locations, on the north side of the South Fork to come in. So they looked at many cable landing locations. And since then, we've done extensive, research on the preferred location on Beach Lane and found that it is a near ideal location on the water side. There's very few sand waves. It's a straight shot from New York State waters. It is very good sand conditions. We think that we'll get full cable burial depth for along this route, and then the onshore portion has to be married with that. And we look at both the environmental impacts, sensitive areas, wetlands, and also the human impacts, how many people are impacted along the route. So all of those things go into the selection of a route, but Atlantic Avenue was one of those looked at. In fact, it's just been looked at extensively in the evidentiary process for the South Fork Article 7 process. And there's lots of testimony out there from experts on both sides of the issue. But we think that we've made a strong case for why Beach Lane should be the preferred location.
Great. So unfortunately, it is at 7:30. So I want to thank all of our speakers, to Joe for moderating, to Dr. Bailey and to Ken for explaining so many items. I am going to launch a quick poll to follow up to see what you thought of the event tonight. So certainly we encourage you to participate in that. I will just give you 30 seconds or so, or actually I can keep talking while you're doing that. We hope you learned some things about South Fork Wind. We will have an opportunity to put this new knowledge to use if you attend local hearings that the supervisor mentioned earlier in the event. They are holding, both the trustees and the town board are holding hearings on the real estate and host community benefit agreements that the town is seeking to enter into with the project. The trustee board meeting is on January 11th at 6, and the town board meeting is on January 12th at 11 a.m. I want to once again thank our event partners, Citizens Campaign for the Environment, Group for the East End, Renewable Energy Long Island, or RELY, and Win with Wind, as well as all of our panelists for this great discussion tonight. We know there are many questions that we weren't able to get to. We are going to work on providing responses to them, working with our panelists tonight. So if we didn't have a chance to get to it tonight because there were very many, we will certainly do that. In addition, if you tuned in late or want to rewatch, this video is going to be available on our YouTube page, which is youtube.com/NYLCV. Thank you to everybody who has participated in our poll tonight. If you, we would encourage you to follow us and our partners, our event partners on social media to stay up to date on all things offshore wind. Our social media handles are on the screen for your reference. If you're not already on our mailing list, please sign up at www.nylcvef.org. And I want to thank you all and have a healthy and safe new year and a good weekend. Thank you so much.
Thank you, Julie, and NYLCV.
Thank you.
Thanks.
Thank you, Julie.